Hi, my name is Blackus, and I did my experiment on Nitinol, which is the smallest, lightest linear actuator available on the planet, which has a very unique property that allows it to change shape. The shape-changing property of Nitinol is applicable in achieving useful mechanical developments to create a reliable source of energy. I developed a closed-form chain model to investigate the curvature during the activation phase of this Nitinol spring. The experiment results showed a reasonable argument with the model. The activation temperatures were between 55 to 80 degrees Celsius. The curvatures of 8 through 20.9 millimeters were collected, and the stresses in the spring were estimated to have reached 100 grams during the activation phase. An activation curvature graph was produced to show the limitations and using approximate measurements in temperature. The experiment implies that temperatures of 80 degrees is most suitable to activate the Nitinol-based spring. According to the data collected, temperatures of 60 degrees weren't efficient enough to completely contract the spring. The model only fully contracted when the temperatures of at least 80 degrees and 90 degrees Celsius were applied to the spring. The curvatures and slope in the model indicate that these are the required temperatures to activate the Nitinol spring. The data collected for temperature were all measured using large increments, which resulted in similar and close readings. Instead of using simple thermometers, we could have used digital thermometer to give a more precise readings. One of the limitations and constraints of this project was how the water was applied to the Nitinol-based spring. Water was heated to the desired temperature and was sprayed onto the spring to activate the Nitinol-based spring. When the Nitinol-based spring was sprayed with different temperatures of water, not all of the applied water covered the surface area of the spring. Due to this haphazardly applied temperature, only part of the spring was activated. Another limitation and constraint of this project was the durability of the spring. During the use of Nitinol-based spring, the stiffness and elasticity of the spring became less effective and worn out after multiple trials. This meant that the Nitinol spring wasn't constant throughout the experiment. From this entire experiment, the results show that it is feasible to manufacture generators made of Nitinol that will react to temperature and create a propulsional force, which can be used as energy. To further research this project, using the data of the relationship between temperature and Nitinol, a generator could be manufactured